Friends, I'm going to demonstrate how to model a 2D crack in Abaqus software. So for that, first we need to open the Abaqus software. So having opened the Abaqus, first we'll set the working directory where we want our files to get saved. So after that, we can save it right away, or else we can save it later also. Okay. So let us create a geometry. For creating a geometry, 2D cell deformable. 0, 200, 200. Then this is our geometry. Okay, done. Now, few more things that we would like to do is for creating a crack, we need to create a partition. So we'll create a crack somewhere here. So we just have to take a line and leave it somewhere. Then check the dimension. Let us round it to 10. So this is the 10 mm crack. Later on, we'll see with the closed form solutions what is the redundancy factor that we are obtaining from this mod based method to the closed form solutions. Then we'll have a validation of this work that we are doing. So we this is the crack. Okay, this will eventually become a crack. This partitioning will eventually become a crack, and because we are going to adopt the control integral method of modeling the crack, there are a few more requirements. That is, we have to define the control integral region. So that will be done by defining a circle. So circle we have to define it small enough, and one more circle is also required to be defined. Okay, so more calculations. What is radius here? Just round it to 2, and this one also can be rounded to 4. Okay, so having done that, this we done partitioning. So this partitioning is done now. The next thing we'll have to do is to define the metal property. For that, we have to go to the property model. We define a material. We are defining in terms of megapascal, and the next thing is okay. We define the material, then define the section, define the section. What is to be done? Solid section, solid homogeneous section. Then just select the defaults, then assign the section to different things. We press and hold the shift button to select multiple region. Then we have to select OK. The green color indicate the section of the metal property has been assigned. And then that I can switch up to the next module where assembly, and while assembly independent step. The next thing is to define the step. In the step, we will just create a generic step with all the default options. Then there is one more requirement in this module, that is in the step module, to create the history output request for the crack. But now that we don't have any crack, if we have to crack, we have to select a crack. There is no crack existing, so we have to go to the next module, create a crack there, and then come back here again. So interaction is the module where there is a provision to create a crack. So in that, first we have to assign a seed. The first step is to assign a seed. Seam is the region where you tell the software that create duplicate nodes. So this is the region which represents a crack, which has broken into three pieces, which has to be selected with multiple selections holding the shift key. And once you select the this thing, it will become a bold line which shows that the seam has been created. After the seam has been created, we need to define the crack details. So for that, we have to select the crack. Okay, what is that? I don't know. Uh, Create crack and assign seam we have already done, right? Create seam option is activated, means already the seam is the same. So manage is also there. Acha, fill out the dialog. Okay, dialog means one dialog is open. That's what I with the other screens also will see. So this dialog is like how you want to create model the crack. So control interval method we are adopting. Then it is asking to do what now first control integral region where this quarter point elements will be created. So after that, select the done. Back with ULR. Then the direction can be represented either in terms of the normal, that is this, with in terms of back propagating direction. So we prefer to define it in the back propagating direction. Then another window will pop on where this new vector is represented. Here we have to just select this part approximately data point element 100.25 left element. This is what we are given the requirement. Node is generally projected and triangular element. If we are selecting the node, then it's part element has to be selected. That we will see in the meshing back. So this cross represents that the crack has been defined properly. Now we have the option to go to mesh or not before. But first we'll do sequentially. So first we'll define the loads. So in this first we'll define uh, the metric condition. So we'll just encaster this region. Now the encaster we just have to do this. Then we'll define the load. Load we are going to define in terms of pressure. Negative pressure is nothing but the stress. Then one more window will open. Now it's 1000. Okay, so now loads and boundary conditions are defined. If a crack is defined, then we have to go to the first we'll finish this one, which was pending here. The crack we have to request for the stress intensity factor. So crack one is automatically some number of control say some four we can give. So then we leave the basic option. So it's done. Default option is if we go, then step is over, interaction is over, load is over, meshing. So for meshing, there is a requirement that sweepable mesh has to be created. So for this region and this region, we are going to create this will be quad dominated mesh. To select and sweepable mesh. Okay, let's get this region into the. Then for this region, what is this? We have to define this thing. We have to define quad dominated again. Yeah. White has not turned. Maybe this yellow is represent the suitable method. Okay. So after that, one more important thing is done is this region something like, this is really the special region. That's grain stress is there, water is there, this linear to vertical to change this situation to be off. You select the geometric order which you like. Select the geometric order. Select the geometric order will introduce an incompatibility between the selected region and the neighboring region. Okay, but then case let us select. Um, then in that case, we'll select both the regions and then we'll go to mesh control. Mesh control element types for both the regions, and then we'll see reduced integration will turn off. But let us see. Now here also it is telling it will do some larger tricky, but how to solve this problem? This meshing is a tricky thing in Abaqus. How to solve this problem? This is a coordinated sheet. Okay. Mm, Dash control. Let the reduce integration be there. The reduced integration be there. Not it is telling incompatible. What? Okay. Right. So now I think it will allow us to have it. Okay, it is integration. Okay. It has allowed us. Let us generate the mesh now. See how it is generated. See, this is very bad. So bad in the sense it is coarse, but let us have a global seed definition. Okay, one window will open which is on this side. So we will just have it to 4. Let's see how it reaches this. It seems that it will lead to better month. So if we go for a finer mesh, even it will be better. So go for that. How we have solved the problem that we have encountered? We encountered a problem of we encountered a problem of what is that problem? What was that problem? We encountered a problem of reduced integration. We had turned off for some integration. This incompatibility has to be avoided. Okay. One more thing, this message is really bad. So can we do something about it? Can we do something about this? If we just bifurcate into two exercises and bifurcate instead of this two, let us see how it is leaving. Let us generate this much again. Okay, this has not helped us much. I just created this. It has not helped us much. Okay, let us leave it for the time being because we have other important things. Make sure that the accuracy that is there because and see what exactly happening and how to debug it. That is more interesting and value-adding process. Let us see if any error is happening. Now we have submitted it. It's running. Expected to give the result in 1 or 2 minutes. Well, let us see. Compatible matches have been done. Rows and tracks have been done. Okay, we are lucky that it has run properly. Basically, it seems that a compatible message should be there and no specific requirements are there. And if we do it, it will be like this, and where we see that. So, more finer the message, the better resemblance will come here. But nevertheless, this thing which will tell us what is the it is saying that is that the one? Yeah, four integrals are there and 6615. Okay, 6615 is the one which we got the result from. Yeah, yes. Okay, so let us do a calculation then. We, uh, we'll do the calculation and we will do one more thing where we are supposed to get the track level precise calculations for edge crack models. At least somewhere on the end of this talk. So this is the formula, the single edge crack platform containment. Okay, this is the formula that we are looking for. So we should be so aside from the basic method is stress, we have to put stress, mean field stress. We can call it as mean field stress. Huh? So, A and field stress. Yeah. So mean field stress is how much? In this case, thousands. Is 10. Then what else? Okay, so for this formula to work, we have to calculate alpha W. So with WIDPH, with how much I took from the so Acha, this has to be 0 till maximum 0.6, but in our case, crack size A by A, the ratio is how much? This 5 is 0.1, so which is within this range, so it can be applied. So, so is equal to 1.12 minus 0.23 into alpha. So this is alpha basically. I'll have to write alpha. I'll write alpha. Working on this. 10.12 55 into alpha square minus 21.72 into alpha q and plus 30.39 into alpha to the power 4. So we have a number and here, okay, let us see what it is giving. So this is alpha, A-L-P-H-A. Yeah. So we have a function, F-U-N-C-T-I-O-N function. So we have to calculate SI means we have to do it is equal to megaparameter into SQRT square root of 1 by pi pi के बाद क्या है pi a into sorry into a इसमें bracket close into f into f we got 6635 which is pretty close to what we got in the this thing. So mesh refinement and other things can solve the problem further accurately. So 6615 is very close. So this is how we are going to end our problem of calculating the stress intensity factor using a 2D track in Abaqus software. Okay.